Assalamu alaikum. The topic of our FYP is IMU based Namaz Khushoo tracker. My group members are Huzefa bin Anwar, Aruba Amir, Ahmad Jawad, Muhammad Faizan. And we are doing our FYP under the supervision of Dr. Danish Nisar. This is our presentation outline and we will going to cover these points in our presentation. Starting with the introduction, we are making IMU based Namaz Khushoo tracker, which is basically a small handy device used to perform error free namaz. As we know that we offer our prayer, and due to noise and disturbance, we often forget our rakat, sajda, or any transition in our namaz. If we forget any rakat or sajda in our namaz, this device will give a small vibration and indicate us that we have done a mistake in our namaz. This is the block diagram of our project. This shows that we will gather different angle readings using IMU sensor. Then we will train our module using machine learning. State machine will detect the transitions and using Bluetooth module we will transfer our data to our Android app and then Android app will display all the information of namaz. Here we are using coin vibration motor. If we forget any transition in our namaz, with the help of a small vibration, we will get to know that we have done a mistake and we have forgot our transition in our namaz. We are also using SD card that will store all the information in it.
Bismillahirrahmanirrahim. Assalamu alaikum. List of quantifiable outcome. In this slide, I will cover the main components and tools involving in our project and their purposes. First is Raspberry Pi. Raspberry Pi will control all the sensors and modules using in our project like IMU sensor, Bluetooth module, data logger module, etc. Second one is IMU sensor. IMU sensor is consists of accelerometer, gyroscope and magnetometer. It will give data according to transition of namaz. Third one is Bluetooth module. Bluetooth module will transmit the information of namaz from Raspberry Pi to Android app running on the mobile. Fourth one is data logger module. Data logger module contain SD card which is used to store the information of namaz. Fifth one is Android app. Android app will show the information of namaz. For example, name of namaz, number of rakats performed, and time reserved in each transition. Sixth one is deep learning algorithm. A deep learning algorithm classify the transition of namaz. These are the transition of namaz: qiyam, ruku, qoma, sajda, jalsa, and salam. All these transitions will be classified using deep learning algorithm. DeepCNN AlexNet. We are using AlexNet DeepCNN algorithm, and till now we have covered these following subtasks: how to use pre-trained network, and how to use deep learning toolbox in MATLAB, and we have also covered the classification of four classes: cat, dog, rose, and button using AlexNet DeepCNN. This is from my side. Thank you. Bismillahirrahmanirrahim. Assalamu alaikum. This is our second main task, which is about classification of four classes: bottle, cat, dog, and rose using DeepCNN and AlexNet. We use 700 images for each class, out of which 70% for training and 30% for testing. After training this algorithm, we get this model net transfer. To test this model, we use different images. This model classifies that image of cat. This is image of dog. This is image of rose. And this is image of bottle. But our main goal is to classify the transition of namaz. First of all, we can train the model of IMU sensor data of transition. After getting the model, we can interlink Python and MATLAB. 1D data of IMU sensor data will be transmitted from Python to MATLAB, and this type of trained model will classify the transition of namaz. This is from my side. Thank you.
Bismillahirrahmanirrahim. Sensor interface with microcontroller Raspberry Pi 4. We use the Raspbian operating system and Python language of these following tasks. First of all, we complete the task the interface of IMU sensor in the form of Raspberry Pi by using Python language, getting the reading of accelerometer, gyroscope, and their complementary filter angles. We can apply the complementary filter to the IMU sensor and its value come in the form of pitch, yaw, and roll. Data saving in the CSV file, we create the CSV file and save the data coming from the IMU sensor. Upcoming task. Training of the model to detect exact transition of the Namaz CSV file of transition data which will be sent from training. Android app design for displaying all the information in IMU sensor. Unity 3D. Unity 3D is a powerful cross-platform 3D engines and user-friendly development environment and 3D animations of the pictures. Assalamualaikum. First of all, we complete tasks in the interface of IMU sensor in the form of Raspberry Pi by using Python language. You can see the signal and print the data of IMU sensor. Secondly, we create the CSV file and save the data coming from the IMU sensor AX, AY, AZ or GX, GY, GZ, MX, MY, MZ. Third task in the we can apply the complementary filter to the IMU sensor and its value come in the form of pitch, yaw and roll. If we move IMU sensor in x-axis, we see the change in roll value. If we move the IMU sensor in y-axis, they will change the pitch value. And last, if we move the IMU sensor in z-axis, you can see the change in yaw value. Thank you.
Here you can see the role, time spent and upcoming task on the table. Our first group member name is Mohammad Fatan. Its role in the project is deep learning and programming related to deep learning. He spent 15 to 16 hours weekly and the upcoming task to him was 1D signal classification and training of the model, etc. Our second group member name is Huzaifa bin Abar. His role is hardware and programming related parts. He spent 15 to 16 hour weekly and upcoming task to him was interfacing with Bluetooth and data logger, etc. My role in the project is deep learning researching and implementation and program related to deep learning. I spent 15 to 16 hour weekly. My upcoming task is Android app design and application, etc. Our last group member name is Aruba Amir. Her role in the project is hardware and the program related to the hardware. She spent 15 to 16 hours weekly and the upcoming task to her was Unity 3D, etc. When we come to the milestone and Gantt chart, we can see that on the left side we have milestone, on the right side we have Gantt chart. When we come to the milestone, we can see that we spent 56 days on literature view, which include IM sensor, Android app design, Raspberry Pi, Arduino, Bluetooth sensor, and deep learning algorithm. We spent 81 days on sensor interfacing with Raspberry Pi, which include IM sensor, Bluetooth sensor, and data logging. We spent 85 days on deep learning algorithm, which include classification using AlexNet algorithm and 1D signal classification. We spent 70 days on Android app design, which include Android Studio and Unity 3D. We spent 15 days on PCB design, 20 days on testing and demo, and 24 days on report writing. When we come to the Gantt chart, we can see the working of every group member and this work in the parallel. So everybody can learn easily and can understand our project and make a good project. Thank you.